Welcome to all of you in this new video. In this video, we are going to learn the procedure of one of the numerical from projections of solid in engineering graphics, and that particular numerical is related to the tetrahedron with some given conditions. So let's see the procedure. So the very first thing is that the given question is related to the tetrahedron of side 50 mm, which is resting on an edge of base on the HP. We have to draw the projections of it if the apex is 35 above the HP. So this is the complete numerical. In this we have to just identify the given information, that is tetrahedron of 50 mm side is given. The resting condition is also given, which is on the edge on HP, and in addition of that they have given instead of axis inclination or surface inclination or slant edge inclination, they have given the condition the apex point of the tetrahedron is 35 above the HP. So before proceeding towards the actual procedure, how to draw the projections, let's first of all understand what is the tetrahedron and how it is look like. So the tetrahedron is nothing but similar to the pyramid, but in that pyramid and tetrahedron, the basic difference is the each and every side of the tetrahedron is having the same dimension, that is 50 mm. So the base edge, the slant edge, the apex point, this is nothing but the information about the tetrahedron in the 3D solid view. But if you are going to observe the line view, there are four faces or surfaces which are triangular in nature and equilateral triangles are there. So the first surface is the base, second, third, and one is on the back side. So the inclined line which is present here, it is called as the edge or slant edge of the tetrahedron. The apex, then by combination of three edges the face will be get created, and the base. In this you can observe the four surfaces are there, triangular in nature, equal in size. Okay, so this is the information about what is tetrahedron, how it is look like, and what are the terminologies of that. So we will take the reference of given numerical and we will try to identify the what is the exact position of the tetrahedron. Okay, so tetrahedron is given of 50 mm side, which is resting on edge on HP with apex point 30 mm above the HP. So if you are going to observe this numerical as per the given condition, let's try to simulate or visualize that object in actual position. This is the horizontal plane and the tetrahedron is there. It is resting on the edge on HP with apex point which is 35 mm above the HP. So this is the actual position of the object. One of the edge is on HP having some inclination of axis, but here axis inclination is not given. Instead of that they have given the condition the apex point is 35 mm above the HP. With the help of such condition we have to draw the projections, means front to top view of the given object. So whenever the projections of solid numerical we are going to solve, we have to identify whether the theta, phi, HP, VP related conditions are there or not. If only one plane related conditions are given, then such type of numerical has to be get solved in the two stages. You can observe here with the help of reference line, such type of numerical has to get solved in two stages. There are different methods. Okay, as per the conventional method, if the object is resting on its edge on HP, so in that case we have to consider the complete base is resting on HP, and in that case we have to draw the front to top view. If the object is resting on its one of the edge of the base, means the complete base is on the HP, so this will be the initial condition of the object, and we have to observe the object from the front view and top view, and we have to create the diagram. In that, the very first step is we have to draw the true shape of the base. That will be the first diagram, and that will be visible in the top view. And as per the first angle projection method, top view will be below the XY line. Okay, this is the conventional or the proper method to start to draw the diagram. But with the help of this shortcut method, we can identify if one of the plane related condition is given, then that numerical has to be get solved in the two stages, and always in the second stage you can observe here HP related conditions we have to use. Okay, which are the HP related condition? That is nothing but HP related condition must be used in the second stage, and that will be above the XY line. And that conditions are nothing but if the theta angle is given with axis with one of the edge of the object, or above the HP related, such as the apex point is above the HP, or one of the edge is resting on the HP. Such type of condition we have to generally use in the second stage, and that will be in the above the XY line. and generally that diagram will be called as a third diagram of the complete solution. Means if the two-stage numerical is there, we have to draw the four diagrams, the front to top view in the first stage and front to top view in the second stage. So the third diagram will be the having the condition which is given in the numerical, and then the second diagram of the numerical will be towards left side of the third one, means towards left side means above the xy line, and the first diagram will be opposite to the second diagram. So the first diagram will be present below the xy line, and that first diagram will be always the true shape of the base of given object. So if the tetrahedron is given, then the true shape of the base will be a triangle. So as per the previous method that we have seen, if the edge is resting on HP, so consider the complete base is on HP and then observe the object. So true shape of the base will be visible from top view. You can follow that method also, or you can follow this method. HP related condition always in the second stage above the XY line, and that will be such as theta above the HP resting on HP. This will be the third diagram. Second diagram will be towards left side of that, and first diagram is towards opposite to that, means below the xy line. And always the first diagram in the projections of solid will be the true shape of the base of given object. Then what is the second diagram? In the second diagram, generally we have to represent the given height of the object or slant edge length of the object or axis height of the object. Okay, that has to be get represented in the second diagram. Okay, then the fourth diagram will be here. So the sequence will be like this. If current numerical we are going to consider HP related conditions, so the first diagram will be below the xy line, second diagram is above the xy line, third diagram is also above the xy line, and fourth diagram will be below the xy line. That will be the sequence to complete this numerical. Till now we have just discussed about the basic theory, where to start the solution and where to end the solution of the current numerical. So the start will be below the xy line and end will be below the xy line. Okay, so please remember the diagram. The first diagram will be true shape of the base. Second diagram, generally we are representing height and axis and slantage of the object. Third diagram, if the theta angle is directly given or indirectly the theta related conditions, yeah, above the HP resting on HP, such type of condition has to be get used in the third diagram. And fourth will be the actual position final diagram. So let's once again see the complete procedure, step by step solution for this numerical. When we are going to start to draw the diagram, before that always try to write down the given data. That is nothing but the shortcut way of representation of the given numerical. So the given data will be like this. The given object is the tetrahedron having the side of 50 mm. The resting condition which is given, resting on edge on HP. So same thing has been written here. Then next condition is given, the apex is 35 above the HP. Then in that case we have to draw the projections of the given object. So the very first step is, once again observe what is tetrahedron. It is having the base edges, 3 base edges and 3 inclined edges are there, or slant edges are there. So very first step we have to draw the xy line. Then if the edge is on the HP is mentioned in the first diagram, we have to draw the true shape of the base. And generally in the true shape of the base, if the edge is on HP, in that case we have to consider the one of the edge is vertical, that is perpendicular to xy line, and keep it on the right side of that true shape of the base. Means you can observe here the first side which is of 50 mm, we have to draw vertical perpendicular to xy line. Then this is the dimension for that. And the true shape of the base of tetrahedron is nothing but equilateral triangle, means all the three sides are having the same dimension. So we have to complete the true shape of the base, that is the equilateral triangle, and the respective resting edge has to be get represent towards right side of the diagram or in the first diagram. So this is the resting edge, you will find out in the third diagram. Then this tetrahedron is having the inclined edges. Then we have to represent that inclined edges by representing the angle bisector. Okay, so the intersection of these three lines is nothing but the actual position of the apex point. When we are going to observe it from the top view, the true shape of the base along with the visible edges also get represented, that are nothing but the slant edges. Then next step is we have to give the nomenclature. Top view without dash, ABC, three corner points of the base, and the apex point is generally get represented O, and O to O is nothing but the axis which is present at the center of the object. Okay, then while representing, generally in the second diagram we are representing the height of the object, then axis height, the slant edge out of these three. So here the axis height is not given, the overall height of the object is not given, but tetrahedron is having each and every side of equal length. So the inclined edges are present. It is also having the 50 mm dimension. So before representing that, one more additional procedure is there that we have to remember. When we are going to represent the tetrahedron in the front view, that is a height representation, always find out which one of the edge or which one of the slant edge is parallel to the xy. Means out of this O2A, O2B and O2C, which one is parallel to xy, and represent that first slant edge in the front view. Such as, if you are going to observe here, out of these three, O2A, O2B, O2C, so the first slant edge, that is O2A, is parallel to xy. So take the projections of apex point up to the xy with normal projection line, and then represent the axis line, chain line. Then the slant edge which is parallel to xy, take the projection of that up to the xy and name that point as a dash. And from the a dash point, we have to consider the 50 mm length of the inclined line and draw the arc on the axis line, means in this way. Okay, and name that point as apex point as O dash because it is in the front view. So front view nomenclature will be with dash. Then join A dash to O dash, that is one of the inclined edge or slant edge of the tetrahedron. Then take the projection of point B and C. You will find out the B and C point will be present here, B dash, C dash. Then we have to connect the or join the points O dash and B dash, that is the second inclined edge, and the third edge which is on the base, that is A dash to B dash. So this is the complete front view of the tetrahedron. So here the procedure that we have to remember: if one of the slant edge is parallel to xy, take the projection of that point initially, and from that draw the arc on the axis. So before that, axis has to be get represented in the front view. So this is the complete first stage of the numerical with front view and top view by considering the base on the HP and keeping the respective resting edge towards right side. Then in the third diagram, just we have to redraw the same diagram which is present in the front view, but having the condition, that is apex related condition. So here the apex point is given 35 above HP, so represent the dimension 35 above the xy line, draw a projection line, and then consider one of the slant edge, that is B to O to B, and represent here from xy line. Yeah, completely redraw the same structure by keeping the position of apex point on the 35 mm distance from HP. Okay, so by redrawing the same diagram, keeping the apex 35 above the HP, the object will be get tilted somewhat, and you will find out the edge B dash to C dash is resting on HP as per the given condition. The side on HP resting on the one of the edge on the HP, that condition is get satisfied here. So generally the third diagram will be the redraw procedure of the second diagram, but the orientation will be different. Then the fourth diagram will be just by taking the projections from each and every point vertically downward, and from the top view towards right side we have to represent each and every point. Likewise, take the projection from A dash vertically downward, take the projection from A point horizontally. The intersection of these two projection will be the new point A1 for the top view. Similarly, represent the remaining point from B dash to C dash vertical downward, from B point horizontal, name that point as a B1. Similarly, C point horizontal, already C dash vertically it is already taken. So the intersection of these two lines will be the C1 point. Similarly, two more points are remaining, that is O dash to O dash, that is axis points. Take the projection from O dash, and from here O point, name that as O1, then O dash upper point, and then O1. So while completing the fourth diagram, always represent all the points by taking the step-by-step projections. Now these are the complete points of the tetrahedron. So now there are some rules to complete the diagram. The rule is nothing but the first rule: the outline of any view are always visible, or outline of any view is always visible. So outline is nothing but by joining the extreme outer points, the boundary region will be get created, that will be always visible. Means we have to connect this point with the help of dark line. The first type of line, continuous thick line, that is a visible line. Okay, so here if I'm going to connect point A1 to B1, B1 to O1, O1 to C1, C1 to A1. This is the outer boundary region or outer outlines of the object. So we have to connect it with the help of dark line. A1 to B1, B1 to O1, O1 to C1, C1 to A1. Okay. So here we have to identify how many edges are present in the given object. So there are total 3 base edges and 3 slant edges. So out of that you can find out the A to B, B to O, O to C, C to A, 4 edges has been represented. Okay, and 2 edges are remaining to represent, that is A to A1 to O1 and C1 to B1. These 2 edges are remaining. So for representing the remaining edges, we have to take the reference of position of observer. If we are going to observe from the top side to complete this view, we have to identify from the remaining edges. The remaining edges are A1 to O1 and C1 to B1. Okay, these are the remaining 2 edges. Then with the help of this arrow mark, we are going to focus on these 2 edges only. So out of that, A1 to O1 means that O dash to A dash is nearer to the observer. So that edge is always visible generally. Okay, the upper edge, upper portion of the object is generally visible to observer. Then in that case, A1 to O1 will be visible, represented it with the help of dark line. Then the second rule is there, if the two lines are intersecting with each other, means consider here A1 to O1 and C1 to B1, these are the two lines are intersecting with each other. If such type of condition is there, then out of that one edge is visible and second edge is invisible. So already A1 to O1 is represented by visible line. So with the help of this rule number 2, we can directly represent that C1 to B1 line, which is already intersecting with the visible line, make it dash. Okay, so this is the complete rule for representing the fourth diagram, which are the visible edges, which are the invisible edges. There is one more reference is there. By the observer position, you can identify if the B1 to C1, this edge is remaining to represent. Try to identify from the arrow mark whether that edge is nearer or away from the observer in the particular this view. If you are going to consider this arrow, the B1, B dash to C dash edge is somewhat away. So that's why we can directly mention the far away edges are generally invisible to the observer. So in that case also we can represent this as a dash, or you can follow this rule also, that if the two edges are intersecting with each other, in that case the one edge will be visible and second edge will be invisible. So this is the complete solution for this given numerical.